Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, welcome everybody. We're going to have two talks today. It's a great pleasure to welcome Professor Sue Moon from KAIST, and she's going to talk about Twitter and her recent analysis of Twitter. It's been picked up by a number of news outlets, PC World, BBC, and MIT Tech Reports. And then Sungjin is going to give a talk on, he's her student, he's going to give a talk on building routers out of graphics processors, right? Okay, thanks.
All right, so I'm going to talk about my Twitter analysis. It's a joint work with Haeun Kwak, Changyeon, and Hosung Park, all my grad students. So I think most of you heard about Twitter, but I don't know how many of you actually use Twitter. Can you please raise your hand if you use Twitter? All right, so I'll do a very brief intro about Twitter. It's a microblog service. You can write a short message, 140 character limit per message. And also you read other people's tweets. Here, I'm following New York Times dining, so I get to read what New York Times write about dining, and then some other people. Also, the Twitter homepage, the typical web page, actually has a list of trending topics. Basically, it's the top 10, top 20 words that appear in all the tweets that Twitter receives. So you can also check out, what are the most, what other people are interested in and what other people talk about. Okay? And I think you hear about lots of events that made Twitter very popular. One of it is, this U.S. Airways jet crashing into the Hudson River. And the first photograph of the accident actually appeared on Twitter before any even local news media got there. One striking thing on Twitter is that in most online social networks, the friendship relation, online friendship, declaration of online friendship is actually mutual. I ask you to be a friend on Facebook and you have to accept my invitation. On Twitter, it's no longer. It doesn't have to be reciprocated. In Twitter, people use this term of following, so I can follow anybody and anybody can follow me. And it doesn't have to be, basically the relationship does not have to be reciprocated.
Can you stop somebody from following you?
Yeah, you can block. Actually, Jitu did that yesterday.
I signed up for Twitter yesterday for the first time. I got 2 random followers in the first 2 minutes. Blocked them both up.
You plan to tweet?
No.
So yeah.
Since I'm going to come sit for the talk, I should at least sign up.
Yes.
I want to mention that Jitu blocked me yesterday. I was one of the random.
He didn't know that was you, probably, Yeah. I was there when he was blocking, so we didn't know it was you. Okay. So weird things happen on Twitter, but typically following on Twitter, it doesn't have to be mutual, okay? And what important thing is people complain that people are not following me back. And if you expect people to follow you back on Twitter, you are on a wrong medium. You should pick another medium because it's a free choice. And I really like that. Okay, so following is basically subscribing to tweets, and not just. And I think you are aware of the Twitter's role in the Iran election. A lot of people on the street would tweet about what's happening on the street when all the major news media in Iran were not reporting about what's happening on the street. So, through this Iranian election and the aftermath, were reported on Twitter. Okay? So in this work, I have 3 goals. This talk, actually, it's a combination of 2 papers. So the first 2 bullets are from our World Wide Web paper. So the first is we analyze the relations on Twitter and see if, what sets it apart from existing online social networks, and then show why we consider Twitter as news media. And then lastly, we propose a new ranking algorithm to identify influentials. Yes.
So it seems the differences lie in what the defaults are rather than something fundamental, because I don't know, I hide like a bunch of my friends on Facebook, and that potentially makes also unidirectional communication.
Right.
So it seems it's
Right.
just the default that's different here.
Right, right. So, I mean, we say Twitter is different in this aspect, but we're not saying that Twitter is not a social network. Okay, we say Twitter has these traits of or characteristics of news media, but we cannot say Twitter is news media, or, I mean, it has like these traits of news media, but we cannot basically make a statement that Twitter is just online social network or just news media. It has, you know, both of it. So media is a means of communication, and when we say news media, we think of radio and TV, newspapers, magazines, and basically the most prevalent feature is that they reach influence people widely. Okay, and so for these three goals, we're going to basically show the following three things. That we're going to show that following is not reciprocated on Twitter, just as Ratul pointed out, that it can be reciprocated. It's basically on how people use it. And on Twitter, we show that it's not used in the typical way as social relationships would work. And then three features about news media. They talk about timely topics, and a few users reach a very large audience directly. And also, you can see the impact that word of mouth spreading of news have. And then we're going to also find a new ranking algorithm based on effective readership, and I'm going to explain effective readership later. So the data that we used for this work was collected last year between June and September. And at that time, there were 41 million users, and we got all the profiles that we could near complete. And there were 1.47 billion following relations, and we have this data set publicly available. And in between June and September of last year, we basically followed all the trending topics and the related tweets. So there were about 4,200 trending topics in that time period and 106 million tweets mentioning the trending topics. And we cleaned spam tweets, removed using clean tweets. And, you know, Twitter is becoming a hotbed of all sorts of research. So almost every conference is, lots of conferences now have papers covering some phenomenon that we observe on Twitter, how to rank users, and all. You can even predict movie profits based on tweets, and also you can recommend users based on like similarities in tweets, or detect real-time events. In this example, there was a paper by Japanese scientists that you could actually give a warning about impending earthquake wave coming to you. And there were like 4 papers with Twitter in their titles at World Wide Web. So, but of all the papers, they use a sample set, small set of the Twitter data. So our paper is basically the first paper that look at the entire Twitter sphere connectivity graph. And I think Twitter is very interesting because it is the first time that's the word of mouth spreading is made so easy to collect data about and analyze. And that's why the Library of Congress has decided to basically put all the tweets on their archive. And it just, I think that act itself represents the importance of Twitter data. So part one, following is mostly not reciprocated. So why do people follow others? It's a reflection of online social relationships. So when we say social, it means some interaction. So it's got to be mutual. Otherwise, it's just one way, one person listening to the other, as if we're listening to the news media of today, one-way communication. And socialists look at reciprocity as the important feature in human life. So is following reciprocal? On Twitter, we see only 22% of user pairs follow each other, which is much, much lower than any reported activity interaction. So on Flickr, 68%, on Yahoo 360, 84%, and on 77 on Cyworld guestbook messages. Cyworld is the #1 online social networking service in Korea. So all these online sites that we consider to have some sense of online social networking interaction going on, the reciprocation ratio of reciprocation is much higher than 50%. And on Twitter, it's lower, 22%. And this is, it agrees with my understanding of how I use Twitter and how most people use Twitter, actually. And it's, people come to Twitter not to interact with people, but mostly for information. Yes, Ratul.
These numbers are impacted if you just take out all the celebrities from the Twitter. It's like I'm saying, are these like normal people screening the numbers, or it's just because some people have thousands of followers and?
Right. So that's interesting. So Twitter is one of the first online social networking sites that these established news media had presence. So Facebook, New York Times, how many people followed like New York Times? Okay. So Cyworld, there were celebrities. So Cyworld, we do have, this is an online service on Korea. So they do have these celebrities, but no news media, actually. So it does play this role of news media.
Yeah. But I guess you could just extend those definitions of celebrities to, you can think of it as non-personal sites, right?
Right.
They're essentially sites managed by professionals, not individual accounts.
Right.
If you took those out, it seems like the model is more like, nobody from New York Times probably visits my webpage. I do go and visit New York Times webpage all the time. That seems like the more correct model here. Ratul and I occasionally see his webpage, he probably occasionally visits my webpage.
Right. So that's a good question. I don't think we took the data out, but we can do it. But still, the reciprocation probably is below 50%, but no guarantee. We'll take a, Stefan?
I just want to point out that it's not just celebrities. It's
right.
actually, many dental practices have now tweet pages where, people actually follow on what they're doing. They're not celebrities.
That's how I'm wondering, professional sites versus non-professional sites.
Exactly,
And then you have to be careful in definition.
Professors are also, I have 4-to-1 ratio followers because I don't follow every student who follows me, so. And second, so now let's talk about, news media traits of Twitter. Users talk about timely topics. Today, the two graphs that I'm going to show here. So this is, the trending topics, how they evolve over time. So the dark green part is the new, and the lighter the color gets, the older it gets, meaning that it maintains some level of, memory. So what used to be a trending topic yesterday remains a trending topic last week or yesterday, but mostly about 50, more than 50% of the trending topics are new. Yes?
What is the definition of old here?
Older than last week.
Older than last
week?
Yeah.
So some topics remain. So meaning that people talk about new things, but they still hold on to some memory. Unfortunate part is we could not actually do the comparison with news media, how much of yesterday's news carry over to today's news, because we couldn't really get some data to compare with and had trouble doing this classifying the CNN news. But here's another view of looking at the data. So we looked at the traffic pattern, and there was a study of YouTube downloading patterns, and based on the downloading pattern, you could actually do this categorization, whether if it's bursty but heavy traffic and lasted long enough, then they would basically consider headline news. Or if the traffic was not, the volume was not as significant as the headline news, but if they persisted, the persistent news. Or if there's like just hiccup, then it would be ephemeral. You would see it just for a very short time, or otherwise, more or less, debris. So headline news actually 54% of the trending topics could be considered headline news, and 7% persistent news. So for example, Red Sox, people talk about Red Sox all the time, sports teams. And then you'd have like somebody, let's say, oh, back in the day it used to be blah blah. Somebody start a trending topic, and people would like comment about, yeah, back in the day I used to be a soccer player, and it would go on for a short time, and and then the topic would dissolve. So from here we can see that more than 60% basically are headline news type. So people talk about timely things, not of course, yeah. And then the next thing is a few users reach large audience directly. So this is the graph that probably you wanted to see. So the blue line is the number of followers a user has. Red line is the number of followings, and so a user has. So we hear a lot about power law. In a social network, you expect to see a power law. So like straight line basically should be a straight line, but beyond 100,000 point, the tail is lifted, and the other part, the following the red line, the tail is dropped. Yes?
How many points are there in that million plus area? Or
about 400. About 400. Yeah, because we have 41 million, so this is about an order like 10 to the minus fifth, so about 400.
Who are these people who have like 100,000 or a million followers?
I'll show you some names later on, but at this time, number one, when the measurement that we took place, it was Ashton Kutcher with more than million, and Barack Obama was number 7, Ellen DeGeneres show, and CNN Breaking News, they were all in top 10 by the number of followers. Yeah. So most of top 400 sites are basically celebrities, or it wouldn't be a simple human being. It would be celebrities or some politicians or major news media. Okay. So what's interesting is you flip it and then number of followings, and it's actually the number drops drastically, meaning that not all the people who have a large following basically reciprocate. So who would reciprocate? Ashton Kutcher doesn't reciprocate. Paris Hilton doesn't reciprocate. But Barack Obama reciprocates because he's a politician. He wants to, give the attention back to there. So the number of people who actually follow more than 1 million people is smaller than actually those who have more than 1 million followers. So going back to the question of reciprocation, so we just cut the tail part off. Then still there's this gap. So because of this gap, I think the reciprocity is going to be fairly low. Yes?
Sir, who follows more than 1 million people?
Oh, politicians, Barack Obama. Yeah. Yeah. Yes?
I guess you did say that you removed the spams, but in my experience, I think towards the back end of the tail of followers, I think they could be spammers as
right.
well.
So there are these 2 hiccup points. So Twitter at the beginning let everybody follow as many people and be followed by as many people. still, a person can be followed by as many people as possible, but you cannot follow more than 2,000 people. So here's a hiccup point at 2,000, and Twitter introduced this restriction like less than 2 years ago. So if you want to follow more than 2,000 people, you have to have good number of followings. So you can be, a spammer cannot come in and follow as many people as they want and write about. Or so. You can still mention people that you don't follow. Huh?
I mean, the spammers cannot do that without creating 2,000 accounts.
Right, right. And getting approval from the tweet. So beyond 2,000 followers, you have to basically talk to Twitter, and I think it's deterrent for people. Yeah. Mm-hmm.
So what advantage does a spammer get by following lots of people?
Well, then you can actually I guess mentioning, if you follow those people, then you can create lists and basically have convenient features on Twitter to, categorize people, group people based on. But nowadays, actually.
But I can just go to that user's Twitter site anyway without having to follow them.
Right, but. You get a lot of tweet spams these days. So people would say, Sumun, welcome to Raleigh. When I landed in Raleigh, North Carolina for the World Wide Web Conference, somebody wrote me, welcome to Raleigh, and I don't know the person. So this kind of spam happens. They call it mention, or you can basically reply. These features you can use without following. So there are these spams, yes. And I'm saying that we did not remove all the spam tweets, but this is followings and followers. So these do not include they may include spammers, early spammers, yes. Mm-hmm. And another question we raise is, are those with many followers, are they as active because they have more followers? So what I plot here is the number of followings, and for each number of followings, how many tweets they've done. So what I'm plotting here is basically average number of tweets and average median number of tweets for the number of followings. And as you can see, the median increases, and this is log scale. So here also log scale. So up to 100 point, the number of tweets increases as you have more followings. And even up to like 10,000, it's not decreasing. And then beyond this blue line is actually, we've done log scale binning and then plotted the, median point. And so it keeps increasing beyond a certain point, up to 10,000, up to 100,000. And then it drops down, to some reasonable level. What I'm trying to show here is that, yes, the more followings you have up to a certain point, up to definitely 100, you are more active. But there was no way for us to get, the date of the user joining the Twitter service, so we could not actually average it over the period. But, as a general trend, so you are more active. And the fact that average is way above median, meaning that there are outliers. So maybe there are outliers because we did not filter the spam traffic, spam tweets very well. But yeah. Sharad?
So why is like 25 and like 250, like those seem to be like special things in the graph?
Right. There are these data points that dip, right? What was it?
Is it because the data that you were scraping, you can only scrape a screen full of stuff and there's a limit to the number of things?
No, probably not. So these two data points, I think, align with the hiccup point at 20 and hiccup point at 2,000. Yeah, but the other ones, what?
That's 250 now.
Yeah, it's a bit, it goes to the side. But this is like binning part. So, actually, I don't have a good clue.
Following, so that hiccup does not apply to those.
Yeah. I have to double check. Yeah. And the other part here is that there are people who are followed by a very large number but never tweet. So there are these celebrities who join Twitter but never tweet. And so I met, Laszlo Barabasi, the author of Linked, and he said, "Oh, I'm on Twitter, but I never tweet. But why do people follow me?" Like, duh, because you're Barabasi. So yeah, there are people who open the account and okay, anyway.
But isn't the x-axis number of followings, not followers? So.
Oh yeah. I think actually, I'm sorry. Yeah, this is. Oh, I think I had labeled it wrong. It's number of followers. Ooh, I think it's number of followers. Sorry. Yeah. And then the fourth one is most users can reach large ones by word of mouth. So this is the interesting part on Twitter. So following direction, we use this right side arrow, but actually if I follow you, what you write, the information follows back to me. So the direction of information flow is the other side. The average path length is 4.1, which is very, very short. And average path length, we basically took 1,000 random samples and then of seeds and then calculated the distance from that seeds to all the rest of the network and then basically planted this. And about with 8,000 samples, the graph is about the same. And the CDF shows that about 70% of the pairs have distance 4 or shorter, and 95% distance 5 or shorter. It's extremely short. So there's an MSN messenger network analysis that was done by Yuri Leskovic and some other person at MSR here. And they show the average length of 6 point something. So it's longer. And this is a directed graph. And so we expect it to be longer because it's directed. But because there are people like Barack Obama that has bidirectional relation with millions of people, still the average path length is very, very short. Yes.
I don't understand what is the path.
So like from one user to another user, the graph, shortest path.
You follow him, that is path length 2?
1. Yeah, 1 hop. So I follow G2 and G2 follows, say, Ming, then the information path from Ming to me is 2. Yes.
So, but this doesn't take into account that many people aren't connected at all, right? Because Twitter has lots of sort of islands, which would be short path lengths, but then themselves not connected at all to the rest of the graph.
So I think we probably looked at the greatest connected component, GCC,
right, yeah.
And I think it covers more than 90% of the users. Yeah. So I forgot the number, but it's the islands not connected to the GCC. Very, yeah.
The question the other version of that question is like, what did you do for pairs that you did not see an information flow at all? Like if you encounter my node, I don't follow anybody. How is that? It's connected in a graph theoretic sense, but not in the information flow sense.
That's a good question. I don't think we looked at it, actually. Yeah.
I don't follow anybody, so you can't like...
Right. So I don't think we took them. So how many pairs actually have no path? Right, no path. I don't think we have that data. Yeah. Uh-huh.
So this is on the range of the following lengths, right?
Yes.
So how would the path length be different if I'm looking at the following or if I'm looking at the reciprocated, only the bidirectional length?
I'm expecting it to be a lot longer and even segmented because the reciprocation was only 22%. So we will have just 1/5 of the links. Yeah,
but then I would imagine the path length will actually be shorter for reciprocal.
It won't be shorter. I am almost sure that it won't be shorter because we looked at, so MSN Messenger network average path lengths are above 5, 6. We have the Cyworld network, which is like basically every Korean joined the network, and the average path length there is more than 4.1. It's 4.7, about 5. I mean, the CDF is slightly to the right side of this graph. So I think if online social network, I don't think there's anything that has path lengths shorter than 4.5, average path length shorter than 4.5, at least reported. Yeah.
Slightly obnoxious question.
Okay.
What am I supposed to take away from this graph? What good is this number? So what had this number been 5.3? What would I change?
That's a good question. To a computer scientist, right?
Yeah, well, why should I care that it's 4.1?
Why are you asking this question about this graph? And
in general, this was a question about all the graphs I've seen so far. It just struck me this accuracy of 4.1 was right there. And
right. So,
basically questioning why is she doing that work?
yeah. Can I answer?
I mean, some of it is reasonable, right? I mean, and so, some of the things I can see.
Some of it, thank you.
Some of it I can see use of. Oh, sorry, I didn't mean to be that obnoxious.
No, it's okay. I'm enjoying it.
It's basically it's a measure of the quickishness of the graph, right?
What?
Yeah.
It's a measure of the quickishness of the graph.
No, I know, but what am I supposed to do with it now?
Right. So now that you know how quickish the graph is,
Yes.
it'll help you do a lot of provisioning of the service itself, right? So if I have n places that I can put my 5,000 servers, right? Which user should go on which servers and where?
Yes. That's a good point.
I also have a comment on this thing that short path lengths, usually less than 6, are properties of small world graphs.
Right.
Information can actually travel very fast in graphs of these properties.
Right. So small world. People say small world, and that in social science it translates to 6 degrees of separation, meaning it's shorter. So one thing is, information actually flows over a much shorter network than human social network, which is true actually. Okay. And now we're going to look at this unique feature on Twitter that you can actually relay somebody's retweet, and so what's an example here is node 0 says, hey, there's free coffee, and node 1, 2, and 4, they are followers of node 0, so they see this free coffee tweet coming from node 0, and node 4 found it particularly useful, so it decides to retweet, meaning that relay. So he tweets it as his own message what node 0 wrote. So it's basically RT is the general convention on Twitter, say it stands for retweet, and quotes the originator and then the message. Okay. So what happens is if node 4 retweets somebody else's original tweet, then node 4's followers, in this case node 6 and node 5 and node 6, they see this retweet and learns about the availability of free coffee. So node 0 would be the original writer, and node 4 would be the retweeter. Yes?
What's the convention? If node 6 were to retweet that message, would it credit node 4 or node 0?
It used to be like chain reaction, but you have to do it manually. But because retweet, this is like a convention that it's a bottom-up convention that users start to use it, and now Twitter supports it as a key option. And nowadays you can see who the original writer, in this case node 0, is, but at the bottom it just shows that it came through who. So you actually have like the original and the hop just before you information. But it used to be able to see all the chain. But you know the writer and you have the time of the tweet, then you can kind of follow it. But it's actually got a lot harder with this new feature on Twitter to actually track retweets. Okay? So anyway, 1 hop neighbor, 2 hop neighbors. So how we construct the retweet tree, here is the writer, reader, 1 writer, multiple readers, still 1, or we can have 2. Okay? So this is the empirical RT trees. So this is a very interesting data because we talk about word of mouth spreading, we talk about information spreading, but how often did we have data to actually analyze how information spread? Does it spread like virus? How do people hear about news? How do relay news? And this is one of the, I think, first times that we have actually data to talk about how information spreads in the social science. So this is like a trending topic, one trending topic over time, how each trending topic any tweet that mentions a trending topic gets retweeted. Okay? And this is a tree. And 98% of the retweet tweets are height one. It's like I say and somebody else's retweets, and that's it. Okay? But the rest of but there are some cases that the chain would go up even to 10. So meaning that it keeps spreading. And the number of users who participate in retweets would almost reach a few thousand, meaning that a single tweet would be retweeted by thousands of people in a rare case. And so this is the additional readers that we pay attention to. That's interesting because if you retweet, you actually bring in additional readers to the new tweet. And what's interesting is like you boost the audience by retweet. So this is number of followers of a source on the x-axis, and y-axis is additional recipients of the retweet. So no matter what the number of followers of the original source is, when your tweet gets retweeted, it buys additional 100, at least median. And average, it can buy up like few hundreds. So this is the power of retweet. Somebody bothers to retweet, on the average, it would bring the retweet would buy extra 100 readers. And the time lag between retweets, 35% of retweet would take place in the first 10 minutes, more than 50% in an hour. So it's like very fast. This is like information spreading at only possible in today's online connected internet age. So the last part is rank users on effective readership. I'm just going to give a key idea on new ranking. So the key idea is your retweets is not always the first to all of your followers. Let's say I tweet about some interesting article yesterday on New York Times Magazine, and I retweet about it, and G2 retweets my tweet because he finds the New York Times article as interesting. But Sangjin also retweets my tweet. Then what if Ratul follows both G2 and Sangjin? Then, Ratul will hear about it from G2 first. So Sangjin's retweet is in a way useless, or it's redundant. Okay? So we're going to count only those who matter, effective readers. Also, not all your followers read all your tweets. I follow more than 100 people. So I cannot read everybody's tweets. I just bother to read the first few pages, and that's it at any time I log on to Twitter. Also, people forget what they have read, and this does happen. After a week or two, did I read this article? Or maybe story, is it especially those tiny URLs, is it the same story or not? So people do read the same story multiple times. So there are different ways to gauge, whether your retweet is really having any impact on the readers. So based on these, we came up with a new ranking algorithm, and I'm just going to show this user rankings. So followers, this one. So this is last year, June, the ranking by the number of followers. Number 1, Ashton Kutcher. Number 7, Barack Obama. You use the following follower graph, and you can run PageRank because it's a directed graph. And actually, the greens basically show overlapping things between the ranking by the follower, number of followers, and ranking by PageRank. They're almost the same because PageRank basically counts the number of links as much. But if you count the number of retweets, actually, then new media, you actually see different ranking. So, of course, people who have a large following, they are influential. But there is also another way to consider influence. One is not, I don't know which one is more important, but there is a quantitative way to measure, that, your story gets, spread by word of mouth. And we propose a new mechanism to quantify that. So summary, I think low reciprocity distinguishes Twitter from other online social networks and has these characteristics. And we are proposing a new ranking algorithm to quantify basically this word of mouth spreading. It's not warm spreading, but it's word of mouth spreading. All right. Other questions? Yes?
So how do you measure the effective readership?
Yeah, so we have a human memory decay model, and we also model, basically give weight, the likelihood of people reading a tweet depending on the number of followers a user has. So the more followers a user has, less likely one would read the tweet. So we take all into the model and then calculate the influence based on the tweet data.
How do you validate this model like that?
Oh, that's the toughest part. That's where we're stuck. Yeah.
You can plant a false story and see what happens to one of the influentials versus one of the non-influentials.
What? Plant a story?
Story.
Yeah, that's a good idea. I'll add you as an author. Yeah, sure.
On that note, how did you remove spammers?
We basically use Clean Tweets, which is a plugin for plugin for browser, one of the browsers, but we don't have a good mechanism.
So if you were to
it's getting harder. Actually.
If you were to compare the spammers on some of these metrics, do they look very different?
So we haven't paid a lot of. I mean, there are other proposals to get rid of Twitter spammers, so we can probably use their mechanisms. And spammers don't have a large following. Spammers mention a lot of people, but their tweets are not retweeted. I'm just assuming. So if we study the retweet patterns, probably they don't matter. But
so these metrics might also be useful in helping you identify spammers.
Yeah. I mean, these would be helpful for the top ranking influencer. I don't know if if I'm on the 10 millionth of the Twitter users, who would care about the ranking? I don't. Yeah.
I guess you have no influence with the Twitter management itself, but if you are, this is an interesting experiment to do. You can, some of the influencers could say that I charge you $2 a month to follow me.
Well, you try that. You try that. I don't know.
That would show how much people actually care.
I do think.
I followed Bill Gates yesterday. Would I pay him $5 a month? Probably not.
Right, right. So that's the emergence of new media. Who would bother to pay to follow you?
It doesn't have to be money, right?
Right. It doesn't have to be. Some
coupons from Bill Gates.
Lunch coupons?
No, he doesn't have to pay me. If I have to give him something. If I had to give him coffee coupons, then will I follow him? That's what I'm saying.
No, he might introduce advertising into his tweets.
I see.
That you might have to then read.
So you,
last one?
Yeah. So you made some of a big deal in the beginning, at least, about being able to see the entire Twitter sphere.
Right.
As you were going through the analysis, I was wondering what could you not have done with a properly sampled graph? Because
average path lengths. Oh yeah, you average path lengths. Actually, you can do samples, right? You did 8,000 samples, right?
Because 2 years down the line, except for Twitter, nobody's going to be able to study the complete graph.
Right. Right.
So in terms of just developing methodologies.
Right. Typically when we originally started the work, we were thinking about looking at degree correlation, clustering coefficient, and these metrics that typically apply to undirected graphs, right? And then we found out that we could not use them to Twitter graphs. So there are other metrics that actually require the entire graph that we don't have good sampling methodology for.
So what kinds of metrics you cannot compute on sample graphs?
Clustering.
I think clustering coefficient.
Yeah.
You could also look at triadic closure. So how many, if you have 2 and you have a third connected to 1, what's the likelihood that you're going to get a triangle and
right.
have the full graph?
So basically network motif analysis you cannot do on sampled graphs, and there are other analysis that I didn't present today that require, that are not there, that for which there's no good known sampling methodology. Yes.
Like if you have some nodes with very heavy, large degrees, your sampling algorithm somehow has to be biased towards accounting for those.
Well, there are sampling methodologies that take into account of the degree.
But you have to know that a priori, right?
No, but
unless you knew it.
I mean, no. You arrive at the node and then look at the node degree,
This
and then
does work, right?
yeah, RESA's work. Right.
The thing is, if you're going to pretend to be sociologists, like sociologists do this all the time.
So just to wrap up, so I think, from the computer scientist point of view, why am I interested in? I'd like to find like systems questions. So one is just as Shrat said, how would you actually support the underlying network system? For example, Twitter is extremely slow, and I don't know how Twitter's underlying system is like, but I hear that their original design was just so bad that they were having trouble scaling up. So they're doing a much worse job than Facebook. So apparently Facebook is doing a lot better. But this kind of transaction, I think, is not something that, I'm not a data person, so I don't know, but this power law workload with very heavy tail, than expected by the power law. This kind of workload, is it something that database people are commonly, using or not? So there's this, workload aspect of it, and I think there are other computer system problems that come from social networking services, and that's one. And there are other algorithmic challenges that either we or computational geometry people or complex systems, the statistical physicists tackle. I think we should just all tackle together. So there are these pots of problems. Yeah, I should stop. Thank you.